Good morning, guys. Today we will discuss the topic regarding the system of limits, fits, tolerance, and the gauging. It is module number 2, chapter number 1. So in this chapter we will discuss what is meant by limits, what are the different types of limits, fits, different types of fits, and tolerance and gauging, and problems regarding the gauging, and one compulsory problem related to the gauging and design of gauging. Now we will initially we will discuss the what is meant by the initial basic definitions is there, introduction part. Now in practically it is difficult to produce a perfect component, and any attempt toward perfection will result in extra cost of the component. Yes or no? It is difficult to produce a perfect component. So in this regard, any attempt any number of attempts to be done to get a perfect result, it will leads to a extra cost of the component. It is related to the manufacturing field. So this is the one of the way to increase the rate of production and to reduce the unit cost of the product. So here no two things in the nature can be identical. Yes or no? So for example, if you are taking any assembling of the two components, there should be a kind permitted variation has an important significance. Yes or no? If the two mating parts has to be done, so there should be a perfect dimension should be we have to maintain with regarding the limits and the fits and the something some difference we can made it in the tolerance. Okay, in this regard we are going to discuss some two to three definitions regarding what is the standard, what is interchangeability, and the selective assembly. These three are very important one. In the standard, nothing but what? It's a set of set of specifications to be needed. We can call it as what? Standard. It's nothing but what any organization having some different characteristics of the component or a system or a product should have to be conformed. So in this regard, the characteristics include, so in standard, nothing but what? It's a set of specification that regarding what it really leads to a certain organization, defined by a certain organization or a body to which different characteristics of the component. So different characteristics, nothing but what? It includes tolerance, and surface finish. It includes tolerance, surface finish, dimensions and material, shape, dimension, material and shape, and methods of use and testing. This is regarding the standard, nothing but what? Set of specification which is done and defined by the certain organization, some leads with to which different characteristics has to be confirmed, nothing but what? Tolerance, surface finish, dimension, material, shape, method of use, and the testing. This is regarding the what is meant by standardization. Now next another one important concept, that is what? Interchangeability component, nothing but what? So if you're in the manufacturing field, if any part did not fit properly while assembly, the same operator will take care of changes and the assembly is to be done. So nowadays in the world of mass production, the parts are manufactured by different operators in different plants and assembled in the another plant. Yes sir, all of you know about this one. Okay, in such condition, dimensions of the various mating parts must lie within the certain variation, so that any one part selected randomly will get assembled with other mating part selected randomly. Yes or no? If it is not suitable with respect to the obtained dimension, means we are not supposed to the operator will not take so much of risk. So what he can do, he may take one component and it is changeable with the another suitable dimension of the another component, and he will do the assembly. So that concept we can call as a what? Interchangeability, nothing but what? It is a component in of which the substituted for the similar part manufactured to the same drawing is nothing but what? Substituted for similar part manufactured to the same drawing. So this is regarding the what? Interchangeability, regarding the interchange. Okay, this concept with this type of system is known as what? Interchangeability. Okay. Now and the last concept that is what selective assembly. Selective assembly means what? In random assembly, any component assembles with another. This satisfies the condition of full interchangeability. If nothing but what? If the any component assembles with any other this satisfies what? This satisfies the condition of full interchangeability. Condition of what? Full interchangeability. But in many cases accuracy may not be satisfied. If the accuracy is not satisfied, if the accuracy is not satisfied by fits, it gives and fits given under full interchangeability. For example, if a part having lower limit is assembled with a higher limit part, then the obtained limit may not satisfy the functional requirement of the assembly. So this is the one of the best example. In selective assembly, parts are graded according to the size. It can be graded. Some grades are in the upcoming next video we will come to know what is the different types of grades. According to the what size, you will get a 0 to 16, totally 18 number of grades is there. Based on that grade we will have some different dimensions. Okay, this technique is suitable when close fit of two component assembly is required. This helps to increase the tolerance. To increase the tolerance, which type of assembly we have to use? We have to use a selective assembly to increase the tolerance. Now this technique is suitable to closely fit of the two component assemblies required. So now we will consider one example. Consider an assembly of shaft and bearing. Assembly of shaft and the bearing. For example, let shaft be 50.50 mm with tolerance of plus or minus 0.01 mm, and bearing is fitted with a clearance of 0.15 mm, having tolerance of plus or minus 0.001 mm. So now the dimension of the shaft to be given by dimension of shaft is given by, that is 50.5 plus or minus 0.01 mm, and the dimension of the bearing is given by 50.65, that is plus or minus 0.001 mm. Therefore this is what the dimension of the this one shaft and the bearing. So in this regard, the maximum clearance is what? We have to find the maximum clearance, that is equal to what? 50.65 minus of 50.49, that is equal to what? 0.161 mm, and the minimum clearance is what? 50.649, one here 6.49, and 50.51 is equal to what? 0.139 mm. So the shaft and bearing can be graded as follows. So the shaft with respect to what? Mm is what? 50.49. How it will get 50.49? So 50.5 minus 0.01, you will get a 50.49, and 50.5 plus 0.01, you will get a 50.651. Yes or no? So this is what a 50.49 and 50.50 and 50.51. So for example, shaft with respect to mm, how it can be represent? 50.49 and 50.50 and 50.51. So like that of bearing, with respect to mm 50.649, and related to the 50.50 50.65, 50.51 related to 51.651. So here 50 is there means minus 0.1 means what? Minus 0.001 means what? 6.49 plus 0.005 what? 651. So 50.50 means minus 0.01 means what? 49 plus 0.01 is what? 50.51. This is what the shaft and selective assembly calculation. So this is what the finding out the dimensions of the shaft and the bearing. Okay, in the next video, this is one of the in short video regarding the introductions of the system of limits, fits, tolerance and the gauging. In the next video, we will discuss the what is the basic definition and what is meant by limit, what is meant by fit, and what is meant by tolerance, and what are the types of tolerance, and so on. Okay, thank you.